Today we are going to discuss about thermal expansion. We know all substance expands with heating and they will contract on cooling. So thermal expansion means the increase in the dimension of body when the heat is applied. Increase in the dimension of the body when the heat is applied. So due to it is a phenomenon of increase in the dimension of the body due to the increase in temperature. I have just giving an example about the thermal expansion. Just see the figure, the first figure. Here you can see the ocean is frozen. On the top of the ocean you can see only ice. So how will the aquatic life is sustained in this? If the ocean is frozen, the aquatic life will be dead, right? But that is not the real situation. We know that. In the Antarctic regions and all, you know, the ocean will be frozen. But it will be frozen only on the top and you can see the slabs of ice. But when you cut the ice, you can see the water there, and the fishes can survive in that temperature. This water will be always at 4 degrees Celsius, even though the topper surface of the ocean is even minus 15 or minus 20, like that. So even though the temperature, the exterior temperature will be minus 15 degrees Celsius or minus 20 degrees Celsius, the innermost layers of the water, the inner layers of the water will be always at 4 degrees Celsius. How come that happen? Because when water becomes ice, the ice expands, and due to the expansion, ice is less denser than water, so ice floats on the water. And since ice is floating on water and this ice acts as an insulator, therefore it will prevent the escape of the heat from the inner layers to the surroundings. So the inner layers, even though the outer layer of water is at minus 15 degree ice, still the inner layer of water will be always 4 degrees Celsius. The ice will prevent the escape of the heat to the surroundings. That is why fishes can survive in Antarctic regions. And this is called anomalous expansion of water. Okay, so when this water freezes, it insulates the water below it from the outside, which means the cold air will act like a blanket. So this is called anomalous expansion of water, and it is because of this property the fish can survive in the winter condition. Okay. Now another example. As soon as we turn a hot water tap, the water comes very fast. But after some time, and the water is cold. But as soon as the hot water starts coming, the flow of water decreases. If we are using a normal pipe, the plastic pipes especially, the flow of water decreases, and after some time the flow of water even may stop. Do you know why? Because hot water is passing through the valve, and this valve may be made up of rubber. It can't withstand with that high temperature, so the rubber will expand, and due to the expansion, the inside tap, it will expand and it will block off the flow of water. Even though it is rubber and even though it is metal, this thing can happen, because when the temperature rises, the metal will expand, the rubber will also expand, so it can block the flow of water. So these are the practical applications of thermal expansion. So the reason why the thermal expansion happens: when any object is heated, the particles start moving in random motion, thus the average distance between the molecules increases, and as a result the object appears to be expanded when heated. You can see that in the picture. See, this is the normal structure of a molecule or a compound. The molecules are very closely packed. Now when we heat up, what happens? The spacing, the molecule will start vibrating with larger amplitude. So all the molecules will vibrate with large amplitude. The atoms also will vibrate with large amplitude. As a result, the distance between the atoms keeps on increasing. That is why the metal expands. Not only metal, all substance will expand on heating because of that. And when an object is cooled, it contracts, which is referred to as negative thermal expansion. Because when the object is cooled, these molecules, all the molecules are coming closer and closer to each other. So the molecules will, the substance will contract. So substance expands on heating, contracts on cooling. Okay. Now types of thermal expansion. The first one is called linear expansion. Linear expansion means increase in the length of the body when temperature is increased. You imagine a copper wire. A copper wire is hang freely and there is a mass suspended. When I increase the temperature of the wire, the length of the wire will increase. So that increase in length is called linear expansion. Now number 2, area expansion. Area expansion is also called superficial expansion. So please note that word also. Area expansion is also called superficial expansion. That is increase in the surface area of the body. You take a metal sheet and heat it. The surface area of the metal sheet increases. Now third one is volume expansion. Volume expansion means expansion in the volume of the body. Expansion in the volume of the body. You take a metal cube and then heat it. So it will expand. Why I am always speaking about metals? Metals are good conductors of heat. They can absorb the heat and they can expand faster. That is why I usually take the case of metals and say. So volume expansion is also called by the name cubical expansion. Area expansion is also called superficial expansion. Volume expansion is also called cubical expansion. So we have already done about the linear expansion. Linear expansion means expansion in the length due to the increase in temperature. So linear expansion means the fractional change in length. That means delta L. L is the length of the body and delta L is the increase in length. So the fractional length means delta L by L. Okay. So just see this equation first, then we will go to the sentences. Just see this equation. I told linear expansion refers to the fractional change in length, which means change in length by original length. So I will be writing like this: delta L by L. Delta L is the change in length, L is the original length. So delta L by L, change in length by original length, is equal to a constant alpha into delta T. Delta T means rise in temperature and alpha is the coefficient of linear expansion. So what I am saying in short is fractional change in length is directly proportional to the rise in temperature. Or I will say fractional change in length equal to alpha into rise in temperature. Rise in temperature is delta T. Alpha is called coefficient of linear expansion. So that is what I have written here. If the solid is in the form of a long rod, then for a small change in temperature delta T, the fractional change in length is delta L by L, which is directly proportional to a rise in temperature delta T. That is why I have written the equation like this. So what is meant by coefficient of linear expansion? Alpha is called coefficient of linear expansion. So what is meant by coefficient of linear expansion? Just see the first statement I have written. It is a parameter which tells us how the size of the object changes with change in temperature. How the size of the object changes with change in temperature. So it is defined as the degree of linear expansion divided by the change in temperature. So alpha is equal to that fractional length divided by change in temperature. Okay, that is coefficient of linear expansion. Okay, now listen, the examples for coefficient of linear expansion. Automatic hot water kettle switches off on its own when the water boils. Why that happens? It is due to thermal expansion. There is a metal. So when the water boils, that metal gets heated up and the metal will expand. And when the metal will expand, the water kettle, the switch is off. The switch will turn automatically off. So that is just a small metal is placed in that switch. The metal will expand, which makes the switch off. Okay. Now, metals expand more and have higher value of coefficient of linear expansion. That is why I am always talking about metals. So, will rubber expand? Yes. Will plastic expand? Yes. But metal expands even much better. That is why we always discuss about the metal in case of linear expansion, so area expansion and also for volume expansion. Now comes the second thing, which is area expansion or superficial expansion. You take a metal sheet, increase the temperature, the area of the metal sheet will increase. That increase in area is called delta A. So fractional area delta A by A. So the fractional change in area is directly proportional to temperature, rise in temperature. Therefore I can write delta A by A proportional to delta T, or I will say delta A by A is equal to another constant beta into delta T, where beta is called coefficient of superficial expansion. Earlier we studied alpha. Alpha is called coefficient of linear expansion. Beta is called coefficient of superficial expansion. So coefficient of area expansion is defined as the degree of area expansion divided by the change in temperature. It is the characteristic of the substance and it varies with temperature. Okay, so that is beta. So if they are asking you to find beta, what will you do? Fractional area divided by rise in temperature. Now the third thing is cubical expansion or volume expansion. It is the change in volume of the body with the rise in temperature. Change in volume of the body with rise in temperature. So change in volume can be given as delta V. So fractional change in volume delta V by V. Delta V by V directly proportional to rise in temperature delta T, or I will say delta V by V is equal to another constant which is gamma into delta T. This gamma is called coefficient of cubical expansion. Gamma is the coefficient of cubical expansion. And you just see coefficient of cubical expansion or coefficient of volume expansion can be defined as the degree of volume expansion divided by the change in temperature. That means delta V by V, that is the degree of volume expansion, divided by delta T, change in temperature. So it is also the characteristic property of substance and it varies with temperature. So we studied three coefficients: coefficient of linear expansion alpha, coefficient of coefficient of superficial expansion beta, and coefficient of cubical expansion gamma. So there are three things. So there is a relation connecting alpha, beta and gamma, and that equation is this: alpha is equal to beta by 2 is equal to gamma by 3. So this is the relation connecting alpha, beta and gamma. Alpha is equal to beta by 2 equal to gamma by 3. So take down that. So from here, what is beta? Beta can be written as 2 alpha, right? Beta is equal to 2 alpha. Now what is gamma? Gamma can be written as 3 alpha. So beta is equal to 2 alpha, gamma is equal to 3 alpha, and alpha is equal to beta by 2 is equal to gamma by 3. Okay, so that is the relation between alpha, beta and gamma. So that's all in this session. Thank you.